Welcome back. Today we're going to talk about slope and y-intercept. Okay, so a few definitions for you. The slope is the constant rate of change for a line, right? We use slope as we talked about how when we have rate of change and it was constant like it is for a line, we call that slope. Okay, it's the ratio of the vertical change to the horizontal change between any 2 points on the line. The y-intercept is the y value of the coordinate when the x value is 0. So on the line, it is the y coordinate where the x coordinate is 0. Alternately, it is the y value of the point where the line crosses the y-axis. So let's first actually determine what the y-intercept is here. So this is our line right here. Okay, should have arrowheads on it. And this is the point where the line crosses the y-axis, right? There's the y-axis. Here's the x-axis. So here's the point where it crosses the y-axis. Now this point is has an x-coordinate of 0 because from the origin we go 0 spaces to the left or right, and we go down 1, 2, 3 spaces, so it has a -3 coordinate for the y-intercept. So the y-intercept is going to be this y-coordinate. So note that the y-intercept is actually not a coordinate itself. It is just the y value of the coordinate. And that's because the coordinate, if I give you a y-intercept, you should quickly understand that the x-coordinate is 0. So I could always throw an x-coordinate in there of 0 because that's in the definition of the y-intercept, that it's the y value where the x value is 0. Now the slope, we talked about finding the slope before. So we want to take 2 points that lie in the intersection of the grid line so that they have integer values for their coordinates. And then let's count going upward here. So we can go up 1, 2, 3, 4, 5, 6. So it has a rise of 6 and a run of positive 1, 2, 3. Okay, so I chose to go between these 2 points. And so I had a rise of 6 and a run of 3. Notice that I get a positive 6 here because I'm going upward 6, and I get a positive 3 here because I'm going to the right by 3, right? A right is a positive movement. Right is positive for the horizontal movement. Left would indicate a negative run. Up indicates, let me put up here, indicates a positive vertical movement, and down indicates a negative vertical movement. So this is the horizontal and this is the vertical. Okay. I could have done it the other way. I could have gone from this point to this point. So I could have gone down 1, 2, 3, 4, 5, 6. That would have been -6, and left 1, 2, 3. That's -3. But remember, these two are the same thing, right? -6 over -3 is the same as positive 6 over positive 3. They both reduce to 2. So I have a slope of 2. Now that makes sense because as I read the line going in this direction from left to right, the line is increasing, all right? So it makes sense that it has a positive slope. So slopes that are positive means that the lines are increasing as you go from left to right, right? Which is the way that we read these. So as the x increases, y also increases. That means that the slope is positive. Okay, let's do the same thing for the next graph. So again, the y-intercept is fairly easy. I pick out the point where the line crosses this is the y-axis here and the x-axis here. So here this point is 0, 5, so the y-intercept is going to be 5. Now I can use one of these points for the slope. Let's use this other point for the slope. So going from this point, we go down 1, 2, 3, 4, 5. So down 5 and left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So left 10. So our rise over run is going to be -5 over -10, which is 5 over 10, which is 1/2, okay? So our slope is going to be 1/2 and our y-intercept is going to be 5. So again, our slope is positive, it has a positive value. That means the line should be increasing from left to right, and it is. So as x increases in this line, y also increases. So as the x values increase, the x values of the coordinates of the line increase, the y values are also increasing. which means the line is going up, right? When the y values increase, it means the lines are going up. Okay, now there is an equation for the line that we can actually pick out pretty quickly once we've determined the slope and y-intercept. So we call this the slope-intercept form of the, or slope-intercept equation, where we have m. We've talked about m before meaning the slope or the rate of change, but now b in this equation is referred to as the y-intercept. And a lot like m, it's just the stand-in, it's our standard variable that we use to indicate y-intercept. So you might be asked by a teacher, like, what's your m and what's your b? Meaning, what's your slope and what's your y-intercept? The y-intercept is also known as the initial value. So that's initial, meaning that in a word problem, oftentimes when x is 0, that's like the beginning of the word problem, right? So that's why we talk about it as the initial value. So using this slope-intercept form of the equation, we can actually go back and put the equation of the lines on the lines themselves, which is a good strategy to do, because on the Algebra 1 Regents that you're going to take next year, they require you to put the equation on the line. So y is equal to 1/2 x plus 5. That's the equation here, right? I put the slope in for this m. This first part here was the slope. And the second part in here was the y-intercept. Now, a common mistake that I see people make sometimes is they forget that you have to put the x here, all right? That's y is equal to 1/2 x plus 5. Sometimes they'll put y is equal to 1/2 plus 5. They'll forget that there's an x there. So be careful, because then you don't have the x and y that are needed to create your coordinates to create the line, right? This is a two-dimensional system, so I should have two variables that represent it. Okay, again, I can go backwards to this one. The equation for this line is, let me get rid of some of the working here. The equation for this line is y is equal to 2x, and I can either do plus a -3, or I can write, because you have a -3 right there, or it's actually a little bit more simplified to write 2x minus 3. So when your y-intercept is negative, just carry that through as a subtraction instead of having a negative sign. Instead of having a plus operation, or an operation of addition and a negative integer here, let's just rewrite that as subtraction, because that combination means subtraction. Okay? And just an explanation of this formula. So remember, where did the y-intercept come from? Well, remember, we are looking for the y value when x is equal to 0. So our question is, what is the y value when x is equal to 0? Well, that's pretty easy to do, because all I have to do is substitute the value of 0 in for x and solve for y. So I'd say y is equal to 3 times 0 plus 8. Well, 3 times 0 is just 0 plus 8. So y must be equal to 8. So y is equal to 8 when x is equal to 0, or the coordinate 0, 8. Well, that means that this number right here is going to be the y-intercept in this equation. Now, in the general form of the equation, y equals mx plus b, this number is always the y-intercept, because think about what happens when you substitute a value of 0 in for x here. Well, m times 0 is always going to be 0, so what you're left with on the right side is just that b. So whatever this thing is here, or really you should think about it in combination with the operation, because if the operation is negative, then you want to think of it as a y-intercept that's like a negative number. So whatever this is right here, it's going to be the y-intercept, okay? And that's the end of the lesson for today. So just one quick thing that I said is, let's say you have y equals 2x minus 8. Well, your slope is going to be 2, and we're going to read your y-intercept as negative 8. Remember, keeping in mind that the standard form of the equation right here has a plus. So if I were to change that into a plus, that would make the b actually be negative 8. You don't have to do all that work, but I just want you to remember that when you have like an equation like this, your y-intercept is going to include, you want to really think of it as everything including the operation. Okay? And that's it. Thanks.